Okay, so we're looking at our next video on discrete random variables. The previous one was on the definition, so we're just looking at a few other types of questions you might get. So I don't know what x is being measured, but I've got the following distribution table, probability distribution table, and I'm going to answer these questions here. Okay, so what's the probability that x equals 0? So the first one, probability that x equals 0 equals 0.064, so it's just straight off the table. Now these other ones, x is greater than 1, you can, just got to rub that out, I include the 1. So x is greater than 1 are those two numbers there, 2 and 3, so probably that x is greater than 1 is 0.432 plus 0.216, 2 and 6 is 8, 1 and 3 is 4, 2 and 4 is 6, so it's 0.648, so that's straightforward. Probably x is less than or equal to 2 is those three numbers there, but it's much easier. I'll just take that number and subtract it. So probably x is less than or equal to 2 is 1 minus the probability that x equals 3, because that's quicker. So it's 1 minus 0.216, 4, 9, so 794. Now this last one, we did this in conditional probability. So what we're looking at is that last one, probability x equals 3. Now that sign means given x is greater than or equal to 1. So what I'll do is I'll just go up to the table again. So the condition is x is greater than 1. So x is greater than 1, so it's those three numbers. Okay. Now the formula, just to remind you, probability of A given B equals probability of A intersection B over B. Okay, so what we're looking at is the events is x has to be greater than 1, which is those numbers there, and the only time it intersects with x equals 3 is that number. So that means we put the intersection, which is 0.216, over the event B, which is x is greater than 1, which we haven't calculated, but we need to calculate those numbers. So 0.288 plus 432 plus 0.216. And I'll just go and get my calculator. Okay, and I'm back, and I've just been pointed out that I made an error there, so that's 784, not 794. Now this last one here, when you divide, make sure you put that number in brackets, otherwise you'll stuff it up. 0.216 divided by open bracket 0.288 plus 0.432 plus 0.216 close bracket equals, so it's 0.231. Okay, so I think that might be the last slide. Let's just check. Oh no. Here's another question, another example of a variation of the question. Show that the following function, probability x equals 1 over 90, 8x plus 2, where x equals blah blah blah, is a probability function. So what we do is we set up a table. So 0, 1, 2, 3, 4, and then we just have to plug the numbers in to the location. So in the first one we've just got 2 over 90. Next one, x is 1, so 8 ones are 8, plus 2 is 10, so 10 over 90 is 1/9. X is 2, 8 2s are 16, plus 2 is 18. I'll leave it as 18 over 90 and worry about it later. 8 3 is 24, plus 2 is 26 over 90. And the last one, 8 4s are 32, 32 plus 2 is 34 over 90, and I'll take that back to 10 over 90. And then to show that, okay, so there's two criteria. All those numbers are between 0 and 1, so that's tick number 1, and they have to add to 1, so we'll just check. So 2, 12, 30, 56, 56, ooh, I've made a mistake, 56, 60, 90. 90 over 90, which equals 1, so both conditions are satisfied. Okay, and I think that might be the last one, so let's have a look. Yeah, so there's the question numbers that you need to do for that one. And we are done. So I'd sort of